Look up at the night sky. See those stars? There are roughly 400 billion stars in our galaxy alone, and scientists estimate that at least 20% of them have Earth-like planets in their habitable zones. That's 80 billion potentially life-supporting worlds in just the Milky Way. Yet, when we scan the cosmos with our most powerful telescopes and listen with our most sensitive equipment, we hear nothing. This is the Fermi Paradox, one of the most unsettling questions in all of science. If the universe should be teeming with intelligent life, where is everybody? The summer of 1950, Los Alamos National Library, 4 brilliant physicists walking to lunch, casually discussing flying saucers. Then, Enrico Fermi suddenly stops and asks a question that would haunt science for decades. Where is everybody? Fermi's mind had instantly grasped the mathematical enormity of the problem. With billions of stars, billions of years of cosmic time, and the apparent ease with which life emerged on Earth, the galaxy should be crawling with civilizations. Some should be millions of years more advanced than we are. They should have colonized entire star systems by now. But we see nothing. This contradiction between expectation and reality became known as the Fermi Paradox. To grasp the Fermi Paradox, we need to understand how vast and old our universe really is. The Milky Way contains 400 billion stars. Conservative estimates, they suggest 40 billion Earth-sized planets in habitable zones throughout our galaxy alone. But here's where it gets mind-blowing. Many stars in our galaxy are billions of years older than our Sun. If life follows similar evolutionary paths, some civilizations should have had a massive head start. They've had enough time to colonize the entire galaxy. Even traveling at a fraction of light speed, a civilization could spread across the Milky Way in just a few million years, a cosmic blink of an eye. So, where are the signs of these ancient star-spanning empires? The Drake equation, created in 1981, attempted to quantify this. When scientists first ran the numbers, they estimated between 1,000 and 100 million communicating civilizations in our galaxy right now. Yet, we still see nothing. The silence is deafening. Perhaps the most sobering explanation is the Great Filter Theory. This suggests there's some evolutionary step so difficult that almost no species ever passes through it. The terrifying question, where is this filter? If the Great Filter lies behind us, we might be incredibly lucky. Perhaps the jump from non-life to life is astronomically rare. Maybe the development of intelligence happens so infrequently that we're truly alone. But if the Great Filter lies ahead of us, we're in serious trouble. Maybe every civilization eventually develops weapons capable of destroying themselves. Maybe they exhaust their planet's resources. Maybe they create artificial intelligence that turns against them. Looking at our own history, the candidates for future filters are terrifying. Climate change could make Earth uninhabitable. Nuclear weapons could end civilization in an afternoon. Biotechnology could unleash engineered pandemics. The silence of the cosmos might not be mysterious, it might be a warning. Perhaps the universe is littered with the remains of civilizations that couldn't navigate the challenges of advanced technology. The Fermi Paradox, it forces us to confront an uncomfortable possibility. Maybe civilizations don't spread across the galaxy because they don't survive long enough to do so. Another compelling explanation is the rare Earth hypothesis. Earth might be the cosmic equivalent of winning the lottery multiple times in a row. Consider what had to go right for complex life to evolve here. We needed the right location in the galaxy, a stable star, a planet of just the right size, a large moon to stabilize our rotation, Jupiter to protect us from asteroids, plate tectonics to regulate temperature, and a magnetic field to shield us from radiation. The list goes on. We needed the right atmospheric composition, the right amount of water, protection from gamma-ray bursts, and dozens of other factors, all aligned perfectly. When we calculate the odds of all these conditions occurring together, the numbers become vanishingly small. Maybe Earth really is 1 in a trillion. Maybe we're not just rare, we're effectively unique in our galaxy. If we're truly alone, then the responsibility for preserving consciousness in our corner of the universe rests entirely on our shoulders. One of the most chilling explanations, it comes from the dark forest theory. This suggests the universe is like a dark forest where every civilization is a silent hunter, afraid to make noise because there are other hunters in the darkness. The logic is brutally simple. Any sufficiently advanced civilization poses an existential threat to every other civilization. Since you can never be certain of another civilization's intentions, and since the consequences of being wrong could mean extinction, the safest strategy is to destroy any civilization you discover before they can destroy you. In this scenario, the universe is full of civilizations, but they're all hiding. Making contact isn't friendship, it's signing your death warrant. The moment you reveal your location, you paint a target on your entire species. The theory suggests that our radio broadcasts and attempts at communication are incredibly dangerous. We're shouting into the dark forest, potentially alerting predator civilizations to our existence. The silence we observe, it isn't the absence of life, it's the sound of civilizations trying desperately to stay hidden. What if aliens don't exist in a form we recognize? Advanced civilizations might be so far beyond our understanding that their activities are invisible to us. Consider how a medieval peasant would perceive modern technology. Radio waves and satellites would be completely undetectable to them. Perhaps we're in a similar position, surrounded by evidence of alien activity that we lack the sophistication to recognize. Advanced civilizations, they might have moved beyond the physical realm entirely, existing as energy beings or uploaded consciousness. They might manipulate matter at the quantum level, making their technology indistinguishable from natural phenomena. Another possibility is the zoo hypothesis. Perhaps we're being observed and studied, but not interfered with. Advanced species might follow a cosmic prime directive, avoiding contact with developing civilizations like ourselves until we reach some predetermined milestone. Maybe they've simply outgrown the need for expansion. Once a civilization masters nanotechnology and artificial intelligence, they might find it more effective to build inward rather than outward. Why colonize 1,000 planets when you can create computational worlds far richer than any physical realms? The search for extraterrestrial intelligence has intensified dramatically. NASA's telescopes, they've discovered thousands of new worlds, many potentially habitable. The James Webb Space Telescope is analyzing distant planet atmospheres, looking for biosignatures. Projects like Breakthrough Listen are scanning millions of stars for artificial signals, processing more data than ever before using artificial intelligence. So far, they've found nothing definitively artificial. We're also discovering just how complex and fragile the conditions for life might be. Every new exoplanet we study reveals how unique Earth's combination of factors really is. The Fermi Paradox isn't just an abstract puzzle, it has profound implications for humanity's future. If we're truly alone, we bear an incredible burden. We're not just responsible for our own survival, but for preserving intelligence and consciousness itself in our cosmic neighborhood. This makes our current challenges, climate change, nuclear weapons, social inequality, not just human problems, but cosmic responsibilities. If we destroy ourselves, we might be extinguishing the only light of consciousness for thousands of light years in any direction. The Fermi Paradox remains one of science's greatest mysteries. After decades of searching, the galaxy remains silent, and we seem to be alone with our questions. But maybe that's okay. Maybe the search itself is more important than the answer. In trying to solve the Fermi Paradox, we've learned more about the universe than ever before, and been forced to confront our place within it. Whether we're alone or not, we're here. We're asking these questions, seeking answers, reaching for the stars. In a universe that might be vast and empty, we've created meaning, beauty, and understanding. The next time you look up at the night sky, remember that you're looking at one of the universe's greatest mysteries. We may be alone, but we're alone together, and in that shared solitude, we've found something that might be rarer than any alien civilization: the ability to wonder, to search, and to hope.